We are looking at lecture 2F. 2 stands for the lesson that we are doing, that is angles and measurements. F stands for the lecture number in angles and measurements. The first part that we are going to consider over here is length of the arc. So let's understand what do you mean by length of arc. In this particular circle, you have AB as an arc where OA and OB are the radius of the circle. Okay. Now, theta is the angle subtended by the arc at center of the circle. Fine. Arc is AB. Let me consider S as length of the arc. Fine. When angle subtended by the circle is 360 degrees, and we know that 360 degrees is 2 pi radians. Why? Because 180 degrees is pi radians, so 360 degrees is 2 pi radians. When angle subtended by the circle at the center is 2 pi, then length of arc, that is circumference of circle, is 2 pi r. When angle subtended by the arc is theta, length of arc is s. So we take the ratio, therefore we get s. S is equal to 2 pi r into theta upon 2 pi, which is r theta. So therefore we can say, if or when angle subtended by arc at center of the circle is theta and theta is measured in radians, then length of arc is r theta denoted by s. Okay. Now, when angle subtended by circle at center of circle is 2 pi, the area of circle is pi r square. 2 pi is, remember, 360 degrees. Why? Because pi radians is 180 degrees. So when angle subtended by circle at center of circle is 2 pi, then area is pi r square. If angle subtended is theta, then what is A? This is area of sector. What do you mean by sector? Sector means piece of the pizza. Area of this shaded region in blue. So from there I get A is equal to pi r square into theta upon 2 pi. So pi gets cancelled. R square theta upon 2, which is half r square theta, where theta is measured in radians. So if or when angle subtended by arc at center of circle is theta and theta is measured in radian, then area of sector is half r square theta. Okay. Let's look at example 1. So now we have got two new formulae. Which are the two new formulae? S equal to length of arc is equal to r theta, where theta is measured in radians, and A is area of sector, which is equal to half r square theta, where theta is measured in radians. Okay. The diameter of a circle is 14. So what is the radius? 7 centimeters. Find the length of the arc subtending an angle of 54 degrees at the center. Let's look at this circle. For example 1. AB is the arc which subtends an angle theta, where theta is 54 degrees. We know that pi radians is 180 degrees. So how many radians will be 54 degrees? We get question mark is equal to 54 into pi divided by 180. So I got 3 pi by 10. So what will be length of arc BX? BX is the arc which is subtending an angle theta, where theta is 54 degrees at the center. So length of arc is r theta, where theta is measured in radians. What is r? 7. What is theta? 3 by 10 pi. So 7 gets cancelled. 66 upon 10. Answer is 6.6 centimeters. Okay. Fine. Let's look at the next question. This is a very important question. One of the very most important questions of this lesson. In a circle of radius 12 centimeters, an arc PQ subtends an angle of 30 degrees at the center. Find area between arc PQ and chord PQ. So this is the arc PQ. which is subtending an angle theta which is given as 30 degrees at the center. I have to find area of this shaded region, which is area between arc PQ and chord PQ. So what is that? What will be that area? Area required will be area of sector QOP minus area of triangle QOP. Now area of sector is very simple because angle is given as 30 degree, pi radian is 180 degree. How many radians is 30 degree? Pi into 30 upon 180, pi by 6 radians. So I got theta is 30 degree, which is same as pi by 6 radians. So now area of sector is half r square theta. Half r square theta. 6 2s are 12. So 12 pi. That is area of sector. To find area of triangle, we need to find area of triangle is half into base OP into height QN. So we have to find QN. How will we find QN? We will draw triangle QNO separately over here. QNO, where this angle is theta, which is 30 degrees. If you observe, sine 30 is QN opposite side upon hypotenuse QO, which is h by 12 because QN is height h. But what is sine 30 half? So you get h is equal to 12 by 2, which is 6. You got the height of the triangle as 6. So what is area of triangle OPQ? It is half into base into height, which is half into 12 into 6, which is 36. So we got area of triangle as 36. But what is area required? It is area of sector minus area of triangle. Area of sector is 12 pi minus 36, which is 12 into pi minus 3. If you want to simplify, you can write 12 into 3.14 minus 3 and simplify as 12 into 14 by 100. Whatever is the answer, 140 plus 28, 168 upon 100, which is 1.68 square centimeters. Okay, we can do that. Okay, next question. The area of a circle is 225 square centimeters. Why they have given area as 225? Because we can find r. Pi r square is 225 pi. So pi gets cancelled. So r square is 225, r is 15. Find the length of its arc subtending an angle 120 degree at the center. Convert this into radians. Whatever is the radian measure, multiply by r. S is equal to r theta. Also find area of corresponding sector. We know S is equal to r theta. We know A is equal to half r square theta. You should try this on your own. Okay. Next, important question. Example 4. The perimeter of a sector is equal to half of the circumference of circle. So suppose radius is r. What is circumference? 2 pi r. What is half of circumference? It is half into 2 pi r, which is pi r. What is perimeter of sector? For sector ABO, if you observe, perimeter is equal to radius plus length of arc. But what is length of arc? R theta, where theta is measured in radians. So perimeter is equal to pi r. Why? It is given that perimeter of the sector of a circle is equal to half of the circumference. Find the measure of the angle of the sector at the center. So you can cancel r from both sides. So you get 2 plus theta is pi. So you get theta is pi minus 2 radians. Pi is 3.14, so 1.14 radians. That will be the answer. Okay. Next question. A pendulum of length 21 centimeter oscillates through an angle of 36 degrees. Find the length of its path. Example 5. So you have a pendulum which is having a length of 21 centimeters. So maybe R is 21 and it oscillates through an angle of 36 degrees. So this is theta. Theta is 36 degrees. To find length of path, say from A to B, we have to find length of arc where radius is 21 and angle is 36, but we should measure angle in radians. Pi radians is 180 degrees. 36 degrees is how many radians? Question mark is 36 into pi upon 180. So it is pi by 5 radians. So what is length of arc? R theta 21 into 22 by 7 into 1 by 5 because this is pi. 7 threes are okay. So this is 66 upon 5. We will do 66 into 2 upon 5 into 2, which is 132 upon 10, which is 13.2 centimeters. That is the answer. Okay. Next. ABCDEFG is a regular octagon. Instead of the circle of radius 9 centimeter, find the length of the minor arc AB. Okay, let's look at the diagram. So we have an octagon. So circle is divided into 8 central angles. Each arc will be one angle subtended at the center. So like that there are 8 because there is an octagon. Okay. So what is measure of this theta? Theta will be 360 upon 8. 8 4s are 32, 8 5s are 40, 45 degrees. What is asked? Find the length of minor arc AB. We have to find length of this arc AB. But I need theta in radians. Pi radians is 180 degrees. 45 degrees is how many radians? Question mark is 45 into pi upon 180. 45 fours, the answer is pi by 4. Okay. So this angle is theta, which is pi by 4. So I need length of minor arc, which is r theta. What is radius of the circle in which the octagon is inscribed? Radius is 9. So what is S? Length of minor arc. Length of minor arc, which is r theta. What is r? 9 into theta pi by 4. So 9 by 2 is 4.5. So this is 2.25 pi centimeters. That is the answer. Okay. Let's do one question from the exercise. We don't do this question. Similar question we have tackled. Perimeter sector, find the area of the sector. We have tackled similar. OPQ is the sector of a circle having center radius 15. Okay, we have done similar question. OAB is a sector of a circle having center at 1 radius 12. We please find the difference in area of sector and triangle AOB. Similar questions we have done, but still we'll do question number 7. OAB is a sector of the circle having center at 1 and radius 12. So, if measure angle AOB is 45 degrees, measure angle AOB, this is 45 degrees. Okay. Now, radius is 12, this is 12, this is 12. Okay. Find difference between area of sector OAB and triangle OAB. We have just seen that 45 degrees is pi by 4. So what is area of sector OAB? It is half r square. Theta is 45, pi by 4. 4 3s are 2 6 are 18 pi. square centimeters. That is the area of sector. To find area of triangle, we have to find the height. This is triangle AOB. This is height. Now let this be N. Now let's draw triangle ANO separately. This is 12. This is 45. And this is height. So what is sine 45? 1 by root 2, which is h upon 12. So h is 12 upon root 2, which is 12 root 2 upon root 2 will rationalize, which is 12 root 2 upon 6. Sorry, 12 root 2 upon 2. 2 6 are, so h is 6 root 2. H equal to 6 root 2. So what is area of triangle AOB? It is half into base OB into height. But what is base OB radius? What is the radius? 12. What is the height? 6 root 2. So 2 6 the answer is 36 root 2. So that brings us to the end of this lecture. We'll continue in the next lecture. Okay.